Now, you might think that this problem is similar to the one we just did about the 5 children being the boys or girls. Here we have wins or losses. But this really isn't. This is a special case of a permutation. And this is how we do it in math. 6 times 5 times 4 times 3 times 2 times 1. And then we divide it by the factorial of the number of wins. Well, since we're winning 4 times, that's 4 factorial. Also multiplied by the factorial of the number of losses. That's 2 factorial. So this really amounts to basically the fraction 6 factorial divided by 4 factorial times 2 factorial. And we know that 6 factorial is 720. 4 factorial is 24. 2 factorial is just 2 times 1, which is 2. So this becomes 720 over 48. And let me use my calculator to see what that is. And it tells me that 720 divided by 48 is equal to 15. So my answer is there are 15 different ways that I could play 6 games of checkers and win 4 of them. Yeah, that was a little challenging problem. Let's continue. Next example. This is a state lottery problem. A state lottery game uses 42 numbers. They're usually numbered from 1 to 42 in this case. Now, to win the jackpot, you've got to pick the correct 7 numbers out of 42. I mean, you've seen the TV show where they have all the little numbers bouncing around on ping pong balls or some kind of little balls, and they bounce around, they blow air, and they open up a little vent, and randomly, in this case, the seven balls just percolate up to the top, and then so they have their 7 numbers. All right? So how many arrangements are possible? And a related question then, what's the probability that you actually win the jackpot? So let's discuss both of those. Okay, here we go. First of all, we've got to ask the question, once a number is picked, can it be reused? Once, for example, the number 35 bubbles up to the top, is there another 35 down there that can bubble up later? And the answer is no. There are just 42 little balls bouncing around, and once one is up there, that's it. It cannot appear up there again. So with that question answered, we go on to the second question. Okay, does the order in which the numbers appear come into play? In other words, when you buy a lottery ticket, do you not only choose 7 numbers, but specify what order they have to be in? And the answer to that is, no, you don't. All you have to have is the right 7 numbers, and nobody cares about what order you pick them in. So order is not important. When order is not important, this is a combination. And here's how we do combinations. The action is picking 7 numbers. So we have 7 actions, so I'm going to make 7 blanks. 1, 2, 3, 4, 5, 6, 7. Okay? Now, how many numbers are available for the first slot? Well, there are 42 numbers available. Once this number percolates up to the top, how many are available for the second one? Well, it's 41. And then after that, there's 40, then 39, then 38, 37, and 36. Notice it doesn't go all the way down to 1. It just stops because we only have 7 actions. Now, because this is the combination, we have to do one additional thing. We have to turn this into a fraction and divide by the factorial of the number of values we have. We have 1, 2, 3, 4, 5, 6, 7, so we divide by 7 factorial. This will give me how many combinations I have. And actually, instead of entering that, I'm just going to do the short way and simply use the NCR function in our calculator. The NCR function is very quick. All we have to do is enter the number that we have to choose from, 42, press the NCR function key, given 42, we're choosing 7. And again, the C stands for combinations. So let me do them in the calculator. Let me actually hold it here and see if you can see this. I don't know if it's going to be too much of a glare or not. We'll try it. Okay, so we have 42. I'll enter 42 in the calculator. All right, I hit probability key, advance it over to NCR. Hopefully you can see that. And once I've chosen NCR, I'll simply enter 7 and push equals. And I don't know if you can read that number, but it's pretty doggone big. It's, I think it's 26,978,328. That's how many different possible combinations, arrangements of 7 numbers chosen from 42 are. That's how many there are. So what's the probability you would win this lottery? Well, you would win it 1 out of every 26,978,328 times that you play. Not real likely to happen, is it?